we're going to delay getting to physics a little while longer while we talk about vector calculus. But first I have a couple additional videos for those of you who might not have had calculus in a while and might need a little bit of a refresher on what a derivative and what an integral are. So if you find yourself in the category where you feel pretty comfortable with calculus and you remember how to take a derivative, and I'm talking a very simple derivative, and you remember how to do an integral, and again a very simple integral, then you can probably skip ahead to the actual vector calculus lectures. But I want to have a couple videos just to remind you, what calculus really is all about. So I can already tell you there are much better videos out there than the one that I'm making, mostly because I just don't have time to write a whole series of videos on calculus. I know a lot of people have found the ones on the Khan Academy useful, and if you just search on YouTube, you can also find a lot of very good lectures on calculus. So what I'm going to do is I'm going to take about 6 weeks of calculus and cram it into like one 10-minute video. So there's going to be a lot of things that I'm glossing over, but I'm going to try and highlight what I see as the important points and the things to keep in mind as we're doing physics applications later on. You'll notice that your book doesn't actually cover calculus until the next unit, until unit N. The reason I brought it before that is because I think it's important to have calculus in order to do things like work and energy. So some of the things that we're going to do a little bit later in this book I don't think can be really completely done without using calculus. And so before we even start getting into physics, I want to make sure we have just a very simple unit on calculus. And so your calculus exam is going to be very simple. It'll be like taking a derivative where you'll have to use the chain rule at most once. Taking being able to calculate an integral, which is going to be something very easy like a trig function that you should know, or an x to the n power, and then like one simple kind of application problem, and that's going to be your exam on that, just to make sure you have these basic skills, because now is the time to catch that before we start getting into the physics, which is going to add a whole new level of complexity. So let's make sure we have the basics down. So after all that rambling, I'll actually start to talk about calculus now. So let's begin by talking about velocity. So we know that velocity is a change in x over a change in time. Okay, and this is the average velocity. So if we know the change in x and the change in time, so in this case, let's first say that the change in time, delta t, is t4 minus t0, and then the change in x will be x4 minus x0. And we'll even define that a little bit further, and we'll say that x4 is x at t4 and x0 is x at t0. Okay, so in other words, where t4 meets our graph over here, this is going to be x4, and then of course this is going to be x0. So the velocity is actually just this line that connects x0 to x4. Okay? But now let's look at a case where we have, what if we subdivide so that now delta t is the difference between t2 and t0. Okay, so we're going to say delta t is equal to t2 minus t0, which is the same as t4 minus t2. So in other words, these are all equally spaced, so this distance on the time axis is the same distance as the t2, t4 distance. So now the velocity is the change in x. So now first we'll look at the case between 0 and t2 and 2. So we'll call this v 0, 2. So this is going to be x at t2 minus x at t0 all over delta t, which is t2 minus t0. Okay. Another way to write this, we could write this as x at t0 plus delta t minus x at t0 all over delta t. Similarly, v24 is the velocity from time 2 to time 4. And that's going to be x at time 2 plus delta t minus x at time 2 divided by delta t. So let's slow down for a second and look at exactly what we're talking about here. So what we're saying is from time 0 to time 2, or time 0 to time delta t, we have a certain velocity. So this is v02. Then from time 2 to time 2 to time 4, we have another velocity, v24. Now the denominator in both cases is exactly the same. It's delta t. Right? In this case, this is delta t. Whereas for the first part, delta t was this entire interval. Now we split it up into two equal parts. But notice that the magnitude of the velocity is much different. And the reason it's much different is because delta x between 0 and 2 is much smaller than delta x between 0 and 4. So what this is saying is we began at some point x0, or x at t0. Then time evolved. We don't know what happened between here and there, but eventually we got to some point x t0 plus delta t, which is the same thing as just saying x at t2. A little bit more time evolves, so we have t0 plus 2 delta t, or t2 plus delta t, x then, which is just the same thing as x at t4. So the slope of this line, so the length of this line is really the magnitude of the velocity. And the velocity is really just kind of is a measure of the slope of this line. But it doesn't have to stop here. We can instead say that delta t is going to be just the distance between two of these points. So in that case, you notice we get something that's coming even closer to looking like this original line. Remember, this yellow line is the actual function, the actual distance that the particle has traveled. And so the more we subdivide it, the smaller we make delta t, the closer we get to this actual line. And this is what a derivative is really telling us. It's saying if we take the limit as delta t goes to 0, so as we keep making these points closer and closer and closer together, that's the same thing. Now, so notice in the first case we had just one line. Then we had to split it up into two sections. Then we split it up into 4. So the number of sections we have is going to go to infinity as we move these lines closer and closer together. But the velocity is really x at t plus delta t minus x at t over delta t at any instant x. So this is giving us an instantaneous velocity. It's saying, it's saying for the same very, very small time interval, how much is the position changing? So in the first case, it changed, in the second case, it changed by quite a lot from x02 to x0 to x24. That's what this should have been, is an x24. Okay? This is the definition of the derivative of dx with respect to t, which is the velocity. This is our definition of a derivative. So in general, for some function f of x, the derivative of f with respect to x, which we'll also sometimes write as f prime x, is equal to f x plus delta x minus f of x all over delta x, and the limit is delta x goes to 0. This is our definition, and this is what a derivative is mathematically. And of all the different derivatives out there, the one that you're going to see the most, or at least the one that we'll use the most in this class, is something like where you have f of x is x to the n. So in this case, the derivative is n times x to the n minus 1. Now this formula is what you would get if you plug this x to the n into there, and you can find that in any introductory calculus textbook. You can find that in the Khan Academy, in any place where they actually work this out in more detail. So here's a very quick and also very dirty look at derivatives and kind of what the most important derivative you're going to need is. And next time, we'll look at, in the next few videos, we're going to look at just some of the most important rules are that we're not really going to derive here, but that you'll need to know and remember while you're taking this class.